For this question, we have the function f of x equals x squared plus 4x minus 5 over x squared minus 3x minus 18. This is a rational function, and we want to consider the end behavior as well as the behavior at each asymptote. So we're given these statements, and we want to fill in what's happening to the y for each one of these statements. Now, the question here specifies that these have to do with the end behavior and the behavior at each asymptote. So let's first use this rational function to find out where the asymptotes are. Let me copy down the function f of x equals x squared plus 4x minus 5 over x squared minus 3x minus 18. And I'm going to start by looking for the vertical asymptotes. The vertical asymptotes can occur when we have some sort of restriction on the domain. So I want to find any restrictions for the denominator. We know that division by 0 is not allowed. But at the same time, we need to consider the numerator as well, because if the function has any common factors, then we have a hole in the graph at that restriction rather than a vertical asymptote. So I want to factor both the numerator and denominator to look for those common factors and restrictions. So let's factor the numerator. We get x and x. 5 times 1 will be 5, and I want a positive 4 in the middle, so I'll put a plus on the bigger number 5 and a minus on the 1. So that's correctly factored. And I'll factor the denominator. When I factor the denominator, I have x and x with 6 times 3 giving us 18, and we want the bigger number to be negative to create that negative 3 in the middle, so negative 6 and a positive 3. So now I can see that we don't have any common factors with the numerator and denominator, and that tells me that I'm going to have only vertical asymptotes, and I can set this denominator of x minus 6 equals 0, the denominator of x plus 3 equals 0, and x equals 6, x equals negative 3. These are my restrictions. So you can see that this is why the question is asking about negative 3 and 6, because these are the location of my vertical asymptotes. So when we find we've found those vertical asymptotes, and now I need to know what's happening with the y values for those points. Now, by definition, a vertical asymptote is going to have x approaching a certain number, and y is either going to approach infinity or negative infinity. So I know the answers to all of these are going to be either infinity or negative infinity. So what I want to do is figure out which one it is. And I'm going to do that with some test points. So let's draw a number line. It might be helpful to see. So with my number line, I've got, I'm going to put my vertical asymptotes on the number line, negative 3. I'm putting it as an open circle because of that being a vertical asymptote, and then 6 as well. And I think it might also be helpful to put in my x-intercepts. Negative 5 and a positive 1 are my x-intercepts. So we have positive 1, which would be around here, and negative 5 over here. The reason why we're putting in those x-intercepts is because I'm going to choose some test points, and I want to make sure that I choose my test points close enough to my vertical asymptote. So I want to pick a test point on either side of this -3. And let's see, to the left of -3, let's choose -4. And to the right of -3, let's choose -2. I also want to choose points on either side of 6. I'll choose 5 and 7. And these are going to help us with our different questions here. This one is -3, x approaches -3 from below. So this test point here is going to help us with that one, -3 from below -3, a little bit less than. We have -3 plus, so this test point here, -3 from above -3, and 6 below 6. This test point will help us with that. And 6 plus, this test point will help us with this one. Now we substitute these test points into the original function, and if the y comes out positive, our asymptote is going to go to positive infinity, and if it comes out negative, it's going to go to negative infinity. So let's test each one of these. We've got our test points of -4, -2, 5, and 7. And we're substituting it into our function. Remember, all we care about here is whether it comes out positive or negative. So we have -4 plus 5. I'm substituting into the factored form. It's much easier to determine the sign in factored form. -4 plus 5, -4 minus 1, -4 minus 6, and -4 plus 3. So this is a positive times a negative over a negative times a negative. So these 3 negatives means my outcome is going to be negative, and I'll be approaching negative infinity. So on this side, my asymptote is at -3. On the left side of that asymptote, I'm approaching negative infinity. And here, y is approaching negative infinity. All right, let's do the next one. -2 plus 5 times -2 minus 1 over -2 minus 6 times -2 plus 3. This is going to be a positive times a negative over a negative times a positive, and we have an even number of negatives, so we're going to get a positive this time. So that means on the right side of that asymptote, I'm going to go to positive infinity, and when x approaches -3 from above, we go to positive infinity. All right, let's try 5. Let's see. Okay, for 5, we have 5 plus 5, 5 minus 1, and 5 minus 6, and 5 plus 3. So this gives a positive times a positive over a negative times a positive, and that's going to give us a negative. So this time we're looking at the asymptote at x equals 6, and when we chose our test point of 5, it was negative. So this left side of the asymptote is going to negative infinity. So we're going to go to negative infinity here. And then for 7, 7 plus 5 times 7 minus 1 over 7 minus 6 times 7 plus 3. This is a positive times a positive over a positive times a positive, and we get a positive. And so on the right of that asymptote at x equals 6, we're going to go to positive infinity. So that takes care of our vertical asymptotes. The other thing that was asked on this question is the end behavior, and the end behavior is determined with our horizontal asymptotes. So with horizontal asymptotes, we have some rules that we use to memorize what the horizontal asymptote is. And those rules are related to the degree of the numerator and the degree of the denominator. So the degree is going to be the highest power on that variable. So for this example, we have the highest power being 2 on both the numerator and denominator. The degree of the numerator is 2. The degree of the denominator is 2. And anytime the degrees are the same, we're going to use the ratio of the leading coefficients for our horizontal asymptote. So this has a horizontal asymptote at y equals 1. And with horizontal asymptotes, by definition, as x approaches infinity, y approaches 1, and as x approaches negative infinity, y approaches 1. It approaches that horizontal asymptote. So we get 1 for both of these. Here we have a rational function, f of x equals 4x squared plus 23x plus 15 over 4x squared minus 9x plus 5. With this rational function, we want to consider the end behavior and the behavior at each asymptote. The end behavior will be when x approaches infinity and x approaches negative infinity. And our vertical asymptotes will be at x equals 1 and 5/4. So what I'd like to do is to find the vertical asymptotes myself. And to do that, I'm going to factor the numerator and denominator. I've got my rational function f of x equals 4x squared plus 23x plus 15 over 4x squared minus 9x plus 5. And let's try factoring. So for the numerator, 4x squared plus 23x plus 15, I'm going to try 2x and 2x. And for the 15, let's try 5 and 3. That would give me 10 and 6, which is not correct. And even if I switch those, it wouldn't work. What I'm trying to get is the correct middle number of 23. So 10 and 6 won't give me that. If I change it to maybe 15 and 1, 15 times 1, that would give me 2 and 30, which is not the right middle number. So let's try, instead of 2 and 2, let's try 4 and 1 for the front, 4x and 1x. And 5 and 3 would give me 5 and 12. That's not right, but let's switch them. Do a 5 here and a 3 here. That gives me 20 and 3. Okay, so we've got the correct factorization now for the numerator. 4x plus 3 times x plus 5. Okay, then for the denominator, Try to factor that. And let's try 4x and x. And then we'll try 5 and 1, 5 and 1. So the middle would be 5x and 4x would give me 9. And we need the middle term to be negative. So let's make both of these negative. So that denominator factors to be 4x minus 5 times x minus 1. So now that you have the correct factorization, you can see where these vertical asymptotes come from. We get a vertical asymptote at 1 from this factor here, x minus 1, and we get another vertical asymptote at 5/4 from this factor here. So those are our vertical asymptotes. Now I'm going to show you a technique to figure out whether the vertical asymptotes will approach positive infinity or negative infinity. By definition, when you have a vertical asymptote, as your x gets closer to that number, the y approaches either infinity or negative infinity. We want to figure out which one. So what I'm going to do is I'm going to set up a number line. And on that number line, we want to make sure that we put our vertical asymptotes as well as our x-intercepts. So we have setting each one of these factors equal to 0, 4x plus 3 equal to 0. I'll subtract 3. That's 4x equals negative 3. Divide by 4, and x equals negative 3/4. We'll set x plus 5 equals 0. Subtract 5 to get x equals negative 5. 4x minus 5 equal to 0. We'll add 5 to get 4x equals 5. Divide by 4, and x equals 5/4. And then x minus 1 equals 0 gives me x equals 1. So we're going to put all of those numbers on the number line in order. So we're going to have negative 5 being the smallest one. Then we have negative 3/4. And 1. And 5/4. I put open circles on the vertical asymptotes and filled in circles on the intercepts. So then what I could do is create a sign chart. I'm going to list each one of my factors on the left-hand side of the number line here. We've got a factor of 4x plus 3, a factor of x plus 5, a factor of 4x minus 5, and a factor of x minus 1. So when you have a factor, it changes signs over its 0. So the factor of 4x plus 3 is going to change from negative to positive over the 0, negative 3/4. So if I draw on each one of these zeros and intercepts, I'm going to draw a vertical line, and it's going to change that factor. It's going to be negative before that 0 and positive after that 0. So then we have a factor of x plus 5, and it's going to change signs over its 0 of negative 5. It changes from negative to positive over that 0. We have a factor of 4x minus 5, and it's going to change signs over the 0 of 5/4. Negative before it, positive after it. and then we have one more factor of x minus 1, and it's going to change signs over its 0 of 1. So negative before it and positive after it. Now it's negative before and positive after because all of these have a positive slope that had a negative slope. Like if your factor was x minus 1, it would be positive before the 0 and negative after it. So if we put all this together, 4 negatives, so for this section, 4 negatives multiply to be a positive. 3 negatives multiply to be a negative. 2 negatives multiply to be a positive. 1 negative is a negative. No negatives is a positive. So we really want to focus on our asymptotes. So we've got this asymptote here at 1. To the left of that asymptote, we have positive. So that's going to go to positive infinity. To the right of that asymptote, we are negative, so that's going to go to negative infinity. Then for the other vertical asymptote, to the left of it, it's negative, and to the right of it, it's positive. So that gives us what the behavior is around those asymptotes. So this is building a sign chart. So this is one way to build a sign chart. Other ways are to pick test points in each interval and substitute it into the function. So then our other two sections here, as x approaches infinity and x approaches negative infinity, we refer to this as our end behavior and also our horizontal asymptote. So we notice that the degree of the numerator is 2 and the degree of the denominator is 2. Since they're the same, we're going to use the leading coefficients to determine the horizontal asymptote. The horizontal asymptote will be the ratio of the leading coefficients, so 4 over 4, which is 1. So our end behavior, the y will approach 1. So as x approaches infinity, y approaches 1 because of the horizontal asymptote. As x approaches negative infinity, y approaches 1 because of the horizontal asymptote. We have vertical asymptotes at 1 and 5/4. By definition, as x approaches these numbers, the y's will approach either infinity or negative infinity, and we use that sign chart to help us determine whether it was infinity or negative infinity. Thank you for checking out my videos. Have a great day.